We are on Unit 6, Unit 5, Lesson 6. We're going to learn about equivalent expressions. So there are 3 objectives. We're going to break it down across several journal pages, but we want to understand the meaning of equivalent expressions. Think of the base word equal there. We want to write and recognize equivalent expressions, and we want to connect real-world situations, models, and expressions. So before we move into page 183, this is journal page 183. We do see a vocabulary word, so we need to review this. So we'll read through this. We have the same value that's expressed. So we can think of a plus 2 plus 3, which would be a and 5. And a plus 5 are equivalent expressions because a plus 2 plus 3 equals a plus 5 for all values of a. A plus 5 and 3 plus 4 are not equivalent expressions because a plus 5 is equal to 3 plus 4 only when a is 2. So if a is 2, it works, but otherwise it's not always going to work. So this doesn't work. So we like to say that we could write equal signs between equivalent, right down here in the chart table, you're going to see that we can use equal signs between equivalent expressions because they are equal for all values of the variable. If you go back up here, there's another thing that we need to talk about. As you learned in Unit 2, the multiplication symbol, the X, can be dropped. The X or the little dot can be dropped as long as it's not between 2 numbers. So, for example, 2 times 3 has a multiplication symbol, but can that be dropped? Right, because if we got rid of it, it would look like 23, and that's a big difference between from 2 times 3, which is 6. So here we have 3c, which means 3 times c. So if there's a number with a letter, we want to try to get rid of these symbols whenever we can to make it as quick as possible. When we get into longer problems, we don't want to have all these extra symbols. So 3 next to a c or a variable letter is the same thing as multiply. A next to b, which could be 2 variables, also means multiply a times b. We could also see a number like this 4 right next to a problem in parentheses, and it tells you to multiply it. So you can just put that number or value right next to the operation in the parentheses, and it means to multiply it. So we're going to practice some of these, and we're also going to see these equivalents being expressed with equal signs in between them down here. So if we look at the examples on this page, we are going to start dropping the multiplication symbol in the expressions and just thinking about different ways to do this. Sorry, I'm reading my notes here. So let's check this out. So this says, for example, A, we have 3 identical packages that weigh 1/5 of a gram each. So we could represent it this way. We could represent it with a plus, with addition, a plus sign, an addition sign, 1/5 plus 1/5 plus 1/5. And that's equal to another way to say it, which is 3 times 1/5, because that's repeated. And that's also equal to 3/5. So we could go from here all the way to 3/5, because it is 3 of those fifths. Example B. So here you can look at 3 identical packages weighing A, an unknown value, grams each. So A, and A plus A is equivalent to 3 times A, which is also equivalent to just 3 next to A. Without that multiplication symbol, you can do that, as long as it isn't 2 numbers. Here we have some problems. So now it looks like they want you to fill this in. 2 boxes holds B books each, an unknown amount of books in each. So we can represent it with a situation and a diagram. And then we can use a plus sign here. So pause this if you need to as you work this out before you reveal my answers. So this would look like B plus B. Okay, and this is also equivalent to multiplying or repeated. So this could be 2 times B, so that's with the multiplication symbol dot, but it's also equal to just 2B without the multiplication symbol. Here we have 4 bags that hold an unknown amount of peaches in each. So they have it written over here, 4 times C. So you just plug it in. So you can I would just draw the same way these others are expressed. I can cut it in half and then cut it in half again, and I have 4, right? So here's C, and C for the peaches. Represented as repeated addition, that would be C plus C plus C plus C with the multiplication symbol and without. You always put the number first and then the letter. Now looks like they have done the repeated addition. So we can solve that. How many of them are here? 1, 2, 3, 4, 5. So we say 5 times D, or 5D. I'm going to put that number first. So we have to come up with a scenario. What could we have 5 of that we don't know the value for?